Hello everyone and welcome to this presentation which is on Redshift user defined function. I am Jatin Goyal and I am an AWS authorized instructor. So soon as we will proceed, I'm going to give you a walkthrough like what exactly we are going to cover as a part of this particular presentation. But before that, let me introduce myself. Let me talk about me in terms of my experience in terms of whatever I'm holding with respect to AWS certification. So I am an AWS authorized instructor, and these are the set of certification I'm holding right now. Like I am a cloud practitioner certified. I'm also holding all three associate level certification, along with the data analytics specialty. I am an AWS Restart accredited instructor. You can also get my details by scanning this QR code, and then you will get a chance to get connected with me over the LinkedIn. Okay, so you can visit my profile if you want. Now, coming back to what we are targeting today. So, today I'm going to talk about Redshift user defined function. Now, before starting with the Redshift user defined function, or before giving you an overview, what Redshift is, it's one of the AWS service, and what's the use of this Redshift. So, Redshift is basically an enterprise level, petabyte scale, fully managed data warehousing service. Okay, it always comes into our mind like whenever we have to choose a particular service, whenever we have to choose a particular functionality in order to drive our application, we needed to understand what exactly we are going to get. Okay, so as I already mentioned you that Redshift is a data warehousing service. Now one question can come into your mind: what exactly is data warehousing? So if I have to explain data warehousing in a very simplest term, I can say that like it is one phase of the data analytics. Okay. Nowadays, every industry, every company deals with data. And we always call data as a huge amount of data because that will help us out to drive our business, to get some decisions, to gain insight into our customers. Like our target is always to provide a better customer experience. So all these things is a part of a data analytic. Now data warehouse is basically a centralized repository in terms of the information that can be analyzed to make more informed decisions. But there are some conditions like whenever we talk about data warehousing, that the data which we are loading into the data warehouse, that should be transformed and that should be ready for the analytical purpose. Okay, so that is short about data warehousing, and that is in brief about Redshift as a data warehousing service. Now let's see the agenda for today. So I will give you an overview of Amazon Redshift. Then I will talk about system and architecture overview. So majorly my area of focus will be on architecture diagram in order to make you understand how Redshift works. I will talk about creating user defined function. Then we will see some example uses of the user defined function. And finally, I will showcase one demonstration to understand the use of Lambda UDF. So these are the pointers we are planning as a part of today's session. Okay. I will also help you out with some good documentation which you can refer. These are the AWS documentation which you can refer in order to get more understanding, in order to gain more insight into all these concepts. Okay. So as I already mentioned you about Redshift, like now if you want to read more about Redshift in terms of its features, in terms of characteristics, I will suggest you a very good documentation which you can get from here. So if I'll basically give you this presentation, you can see the Redshift system overview. And from here also, you can get an idea that it's an enterprise level, petabyte scale, fully managed data warehousing service. Now, there are so many topics which you can go through if you want to get into deep dive about the Redshift. And like I promise you, AWS has very good documentation available. So this is a best place to start with for any of the AWS service. So right now I'm talking about the Redshift. So best place to start with the AWS. You can also see the tutorials. Let's say if you want to get some hands-on for this service, you can always visit to the tutorials and you can get an idea on. Let's start with the system architecture overview. Let's try to understand the data warehouse system architecture. Okay. So if you will see this particular diagram, in this diagram, I have different elements, which is basically giving you an introduction about Redshift data warehouse architecture. I will talk about some of the applications and we will see the flow of these pointers which are included in this particular diagram. So first thing, if you will see, we have some client applications. Now, what are the client applications? Client applications are one from where the request will be initiated. Okay. So you can see these are the client applications. Okay. So what Redshift does? Redshift basically integrates with various data loading ETL, which is extract, transform, load tools, and business intelligence reporting, data mining, and analytics tools. Because if you have to start the flow of your application, the first thing which will be required, that will be data. And now there can be different sources of data from where the data can be collected and data can be loaded into the Redshift. Once the data is present into the Redshift, you will need the integration, because your major goal is to analyze the data in order to drive your business, in order to gain some insights, or in order to get some useful decisions. Okay. So either you can initiate a request using some client applications, you can execute some queries, some standard SQL queries, you can perform some complex operations, complex join operations, or you can also integrate it with the BI tools, and then you can perform the visualization. Okay. So Redshift is based on open standard PostgreSQL. So basically, most existing SQL client applications will work with only minimal changes. Then we have clusters. So Redshift will be defined in terms of Redshift clusters. What Redshift cluster is? It's the core infrastructure component of a Redshift data warehouse. Okay. This cluster will be composed of one or more compute nodes. Okay. And in the background, if I have to elaborate it in a very simplest term, there will be EC2 instances which will be running. As a part of a cluster, there is a concept of leader node and compute node. Okay. So leader node will be the one where the execution plan will be there. So there will be an execution plan in the leader node, and based on the execution plan, the data will be distributed to the compute node for the processing part. Okay. So you can say that leader node manages communication with the client program and all the communication with the compute node. So you can act as a central intermediate which is interacting with the client applications as well as with the compute node. So it is parsing and developing the execution plan to carry out the database operation. Compute node. So leader node will compile the code for individual element of the execution plan, because our execution plan is present on the leader node, and it will assign the code to the individual compute node. Okay. Whenever we talk about computing, like if we are processing something, we also need the storage. So we have Redshift managed storage. So data warehouse data is stored in a separate storage tier, which is Redshift managed storage. Okay. And what this Redshift managed storage provide? It provides the ability to scale your storage to the petabyte using the Amazon S3 storage. So you can see here. And we know S3 is one of the cost effective storage option which is available in the AWS. Other than these components, obviously you will require the networking, because let's say if you want to get some isolation, or if you want to design your architecture in a particular network, you will need the internal networking. So Redshift always takes the advantage of the high bandwidth connections, close proximity, and customer communication protocols to provide you private high speed network communication between the leader node and compute node. Okay. You will need databases. So a cluster contains one or more databases. User data is stored on the compute node, and the SQL client or the application client will communicate with the leader node, which in turn coordinates the query run with the compute node. Okay. If you're looking for the more description on this particular architecture diagram, what I will suggest you can follow this particular documentation. And here you can see the architecture diagram overview in terms of different components. You can see here we have client application, we have clusters, we have leader node, we have compute node, we have Redshift managed storage, some node slices, internal network, databases. All these components are here. So you can also get an overview of the system architecture from this particular documentation. Okay. So now we got an understanding what exactly we are using Redshift for. So we are loading the data into Redshift from different data sources. And then we are analyzing that data using some BI tools or by initiating the request from the client application and executing some complex queries or complex operations. Okay. Now, there is one more concept in the Redshift, which is the user defined function. So, let's talk about the user defined function. What user defined function is. So, what you can do, like basically, if you will go here in the creating user defined function documentation, you can see like you can create a custom scalar user defined function using either a SQL select clause or a Python program. What's the purpose of this function? Now, think in a perspective. Let's say if I'm writing the SQL query, and as a part of my SQL query, I have to perform some complex operations. Okay. So whenever we always talk about that I have to perform some processes, I have to perform some complex operation, we say that everything is possible with the help of a code. If a developer is writing a piece of code, then we can make anything achievable with the help of the code. Okay. So similarly, here we can create the user-defined function, and the purpose of the user-defined function is to perform the complex operations while you are executing the queries. Now, other than this SQL select clause or a Python program, you can also create the AWS Lambda UDFs that use custom functions defined in Lambda as a part of your SQL queries. And our goal for today is to talk about Lambda user defined function only, where I am going to show you one demonstration how we can make use of a Lambda user defined function to perform some operations. Okay. Let's talk about little bit on Lambda because we have to understand Lambda. So Lambda is an event-driven serverless compute service. Okay. So these Lambda UDFs will enable you to write complex user-defined functions and integrate with third-party components. We know, like one of the very good use case of Lambda is it provide you integration with different AWS services, or you can also have the integration with different third-party component. Okay. They also can help you overcome some of the limitations of current Python and SQL UDF. So you can understand this with the help of an example. Let's say if you talk about the Lambda UDF, you access network and storage resources and write more full-fledged SQL statement. Okay. You can also create Lambda UDF in any programming language which is supported by Lambda. We know, like being a serverless compute service, Lambda provides you a platform where developers can run their code without need to worry about the underlying infrastructure. So Lambda provides you supports for different programming languages. You can choose a programming language, or you can also use a custom runtime. Okay. So this is about user defined function. Now, next thing is you can see some example uses of the user defined function. So they have explained it in a very pretty well manner. You can see like you can use user defined function to solve business problems by integrated Redshift with other components. So some of the examples are here, like accessing external component using Redshift Lambda UDF, translate and analyze text using SQL function with Redshift, Amazon Translate, and Amazon Comprehend. Okay. You can also go through a respective documentation if you want. Let's say I will open this, accessing external component using Redshift Lambda UDF. So this is a very good blog you can study, and you can also see the solution architecture. If you want to have a demonstration, if you want to just practice it by your own in your AWS account, you can follow the steps mentioned here and you can complete this demonstration. Okay. So there can be several use cases of the user defined functions. Now coming back to what we are going to do, like what I'm going to showcase you. So I am going to talk about using Lambda UDF with the Amazon Redshift. Okay. So let's start with the demonstration. So we will need some prerequisite for that. First thing which we will need, that will be AWS management console account. Means you should have an AWS account. Okay. And I am going to use management console interface for this. So if I will talk about the prerequisite will have, you should have an AWS account with the administrative access to complete this exercise. Okay. So what you can do, let's say if you have an account and you are a root user, you can create an IAM user and you can provide the administrative access to that particular user. Let's start with creating an IAM role first, because we know IAM role help us out in order to allow the services to interact with each other. So let's start with the IAM. You can simply search for the IAM in the search bar and you can open this IAM console here. What's the task? The task is to create the IAM role. What's the purpose of this IAM role? We are going to create this IAM role for the Redshift cluster, which is used to provide access to the Lambda function. Okay, you can choose a region of your own choice because IAM is a global service, so there is no need to choose a specific region. But when you're going to talk about or when you're going to launch Redshift cluster or writing a Lambda function, at that point of time, what you can do, you can choose a region of your choice. I'm going to drive this workshop in a Mumbai region. Okay, let's go to roles, and here I will click on create role. You can choose a trusted entity type as a AWS service, and here you can search for the Redshift. Okay, as you will search for the Redshift, you have two options. So search Redshift customizable. It allows Redshift cluster to call AWS services on your behalf. And now I'm providing the power user access to this particular IAM role. So I'm using a manage policy. If you want, you can also create an inline policy. That's your choice. I'm using the manage one. I'll go to next. I'm providing a role name. Let's say demo role UDF. And you can also append the date, like in order to make it unique. Okay, so you can follow the naming conventions. If you have a similar kind of role which is existing in your account with the same name, you can get the error. Okay, so you can make it unique. Okay, so I'm just making demo role UDF Lambda, something like that. Okay, I'll scroll down and I will click on create role. So I'm role is ready. It's creating the role. So I'm role is ready. You can sort it on the basis of creation time. And you can see this is the role I have created. I'm going to use this role soon. Okay. Next thing which I will do, I will open Redshift console. So you can simply type Redshift in the search bar and you're here. It's always better to open different tabs when you want to work parallelly on different services. Okay. Instead of overriding a particular console, you can simply open a service in a new tab. So I'm choosing a Mumbai region, as I told you, and I am going to create a cluster in the Redshift. You can also read about Redshift from here. Accelerate your time to insights with fast, easy, and secure analytics at scale. Okay. And you can see about pricing and cost. It's always better to understand the pricing before you are using a particular service. So you can see if you are in the free tier, you can understand the free tier limits, and when the free tier limit will be exhausted, what are the charges you will have to pay. There are some good documentations which are available here: getting started with Redshift, overview and features, free trial, evaluation and POC support, some documentation, purchasing a reserve node, query your S3 data lake with Redshift Spectrum. Okay, so if you want to make use of this documentation, you can do that. But what we are going to do, I'm going to create a cluster for now. Let's create a cluster. You can give any name of your choice. So I'm giving a name, Redshift Cluster UDF. What are you looking for? You have two options to choose from. Either you can choose a production or either you can choose a free trial. I'm choosing a free trial. One good thing is when you are choosing a production, you can see here that it will also help you out in order to choose what are the node type you should basically decide. Because if I will talk about Redshift cluster, there are several parameters which will be required to launch a cluster, and these parameters also impact the cluster performance. So node configuration is one of them. Okay, so if you are choosing the production one, you can basically ask AWS to help you out to choose which type of configuration will be required. So this is the option, help me choose. You can explore this if you want, and then it will suggest to you the node configuration. But I am going to use free trial for this particular demonstration. I will keep these options as default. In the database configuration, if you are going to use any external client, you will need these connection strings, okay, in order to connect to this Redshift cluster. But as a part of this particular demonstration, I am going to use Query Editor version 2, which is one of the built-in option available in the management console to connect to the Redshift cluster. But you can provide a user password. Just read the naming conventions you should give when you are providing a password here, and click on create cluster. The cluster will be created. Currently, the cluster is in the creating status, so we'll have to wait till the cluster will be available. So it takes time. So let's wait for a couple of minutes, 2 to 3 minutes, and then a cluster will be available. In the meantime, if you want to explore the Redshift documentation, you can. You can go to the best practices. You can talk about the best practices of the Redshift. So these are some of the topics like conducting a proof of concept for Redshift, Redshift best practices for designing table, Redshift best practices for loading data, Redshift best practices for designing queries, and working with recommendation from Redshift advisor. So here, our major goal is to understand how we can make use of this user-defined function as a part of Redshift cluster. You can also create a cluster, and if you want to perform several demonstration on that cluster, you can do that on the same cluster. You can also take a snapshot. You can also take a backup in case something will be wrong. You can restore your backup in order to get the access to the data, or in order to get the access to your tables, which is already present into the database. So all these things you can do. And you can always go to the documentations. There is one more thing I want to share with all of you. In the meantime, this cluster is getting launched. You can always go to AWS Knowledge Center. This is a very good documentation which is available in AWS. And the best part is, like as a part of our day-to-day work, sometimes we need to troubleshoot some scenarios. We are looking for some blocks which can help us out in order to understand the root cause. So let's say if I'm talking about Redshift here, under analytics category, you can scroll down, you can see this Redshift, and you will see a lot of blocks here. How do I resolve access denied error using Redshift Spectrum with Amazon S3 bucket? And there will be a lot more. Okay. So you can read these blocks for extra knowledge. Let's see the status. What's the status? So let me go back to my Redshift cluster. Let's see the status here. It is still in a creating state. Not an issue. What we can do? We can create a Lambda function in the meanwhile. So let's go to Lambda. I'm opening a Lambda console. And in the meantime, let's create a Lambda function till the time our cluster is getting available. So before connecting to a cluster, we can also create a Lambda function. This is my Lambda console. You can go to create function. You can give a function name. We have different ways by which we can create a Lambda function. So I'm choosing the one called author from scratch. In the function name, I'm saying UDF Lambda Redshift demo. You can provide a unique name. You can choose the runtime. You have different programming languages available. So using Lambda UDF, you can create the function in any of the programming language which Lambda supports, and also you can make use of a custom runtime. That's up to you. I'm choosing runtime as Python 3.8. Let me choose that. Next thing will be in the permission tab, but I will create a new role with a basic Lambda permission. I'll not change any default execution role. I'll create a new role with the basic Lambda permission. And what basic Lambda permission talks about, the basic Lambda permission talks about that Lambda can put the logs in CloudWatch. So simply click on create function and your function will be there. So I'm going to replace a piece of code in the Lambda function that I will do once my function code area will be visible. So I'm going to refer this piece of code here. This is a piece of code I'm going to refer. Let me take this and then I will talk about this piece of code, what exactly this piece of code is doing. I'm here. Let's go to this function code area. So I'm replacing this existing one with a new one. It is here. This is a Lambda handler. And what exactly I'm doing in this code, I'm passing two arguments to the Lambda function, and those two arguments are the quantity and price. If you will see, I'm passing the arguments. So I'm taking two arguments. Argument 0 is quantity, argument 1 is price. So these are the column values which I'm passing as a parameter. And what it is returning to me? It is returning to me an additional calculated column which has the value of quantity into price. So this is what it's returning to me. So I'm performing a simple processing using this Lambda user-defined function. Simply click on deploy. And wait for this function to be ready. So this function has been successfully deployed, or you can have successfully updated the function. Let's go back and let's see the status of the Redshift cluster. It's available. Next thing what we will do, let's open it. I will attach a role. So go to properties. In properties, if I scroll down, I want to associate IAM role which I had created. So click on associate IAM role. I had created this role, demo role UDF lambda. Let's quickly verify this if it is the same one. Yes, this is the same. So let's select this and click on associate IAM roles. So the status it's adding, and the status of my cluster is modifying. So let's again wait for this to be available. I'll go here. In the meantime, you can explore this query editor. So this query editor help you out in order to connect to Redshift cluster. So I'm going to use this query editor. Okay. This is my cluster, Redshift cluster UDF. What I'm going to do, I am going to load the data into this Redshift cluster UDF. So for that, what I will have to do, I'll have to create a table first. So purpose is to insert the data into the Redshift database. So I'm going to use this syntax. I'm going to create a table called product details. Let me create this table. So I'm using the syntax here. Let's quickly check the status by navigating back to your console. It's available. Great. I'll come back here and I'll execute this query. You can simply press Control Enter from your keyboard, or you can simply click on Run. Let's wait for this query to be executed. These are the columns in this particular product details table, or you can say this is a schema of this table where I have defined the column name and the data type. It's taking time. Let's wait for the result to be appeared here. So once the result will be appeared, I will be able to see this particular table. And my next step will be to insert the data into this table. Okay. Let's do one thing. Let's stop this query. And let's quickly verify first. Do we have this table present? Otherwise, we'll execute this query one more time. Okay, I don't have. Let's execute this query one more time. Okay, this time I got the result. It would be a case then when I was executing a query at that point of time, my Redshift cluster wasn't available, and that's why it was taking a long time. But now you can see the query got executed, and now the table will be available here. Okay, so you should always be aware how to troubleshoot these kind of issues. Let's expand it. And here you can see we have this product details table. The next thing which I will do, I'll have to enter the data into this product details table. So I'm saying insert into product details, and these are the columns: product number, product code, quantity ordered, price each, product line number. Okay, let's take this and take this from here. I'll copy it and I'll paste it. Let's run the query. And now data is present here. You can always execute select star to see if the data is present from the product details or any other table you are creating. And I can see this is the data which I have inserted. Okay. Now what's the next step? What we have now, we have a Redshift cluster with us. We have the Lambda function, which we have made ready with us. We had also connected to a Redshift cluster using this query editor. We had created one table and we had inserted the data into that table. Now it's time to create a user-defined function. So we are going to create a user-defined function, which in reverse will call a Lambda function. So let's do that. This is a syntax I'm going to follow, like create or replace an external function. I have given a name. You can choose any name of your choice. So this is a name I have given here. After this, I have passed this Lambda function name, which I had created. And here I have passed the IAM role ARN. I have used one parameter called varchar table. If you want to go through this parameter, what you can do, you can simply open this documentation and you will get an idea about creating the external function. Okay. So you can see like this is a required privileges. These are the privileges for the creating external function. Either you should be a super user or either you should be a user with some create or replace external function privileges. This is a syntax. And if you will scroll down, these are the parameters which you can pass. So the parameter which I am using, that is stable. So what this particular clause will help me out, it will inform the query optimizer about the volatility of the function. Okay. You can see about this particular parameter. So this parameter says that if you are giving the same argument, the function is guaranteed to return the same result for all the rows processed within a single statement. Okay. So that's how you can read more about the parameters which you can pass while you're creating a syntax. Okay. So let me go back and let me use the syntax. The one change you will have to do, like as I had created one lambda function, you will have to import JSON as a library, as a dependency, because I'm using this. Otherwise, you'll get the error. So that I have done. I have imported the JSON and I have deployed the changes. So you can also incorporate that. Now, if I'll come back here in my query editor, I can execute this. If I'll scroll down, this is the function which I am going to create. Let me do that. Let's execute. And you can anytime verify the function you have created under this hierarchy. You can see we have this function user defined underscore redshift underscore lambda. So this is a function which we have created. I had a few more functions which I had created, but we are going to talk about this one. Okay. Let's execute a query. I'm going to select certain records. Let's give a try. Try to execute it. And let's see the result. So can you see we have one more column here called total price. What this total price is coming from? So this total price is basically returning you the result which you have calculated here as a part of quantity and price. So there were two arguments I had passed in my lambda function and I was returning the multiplication of these two arguments. So when I had executed this select query, I am creating one alias, which is total price. So whatever result your lambda function will be returning, that result will be displayed here into this total price. So in short, this is how you can perform complex calculation too. This is a demonstration where I had performed a simple calculation, but you can also write a complex logic using the user-defined function, and then you can call those user-defined function as a part of a query execution. So this is what I wanted to showcase you as a part of our presentation. I hope you have got some understanding about user-defined function and have also got an overview about Redshift. So thanks a lot for being a part of this particular session, for staying here. I hope the session was informative and you have gained something from this particular presentation. Thanks a lot. Bye-bye and take care.